Good morning, students. Welcome to the chemistry online class. So, in the first piece syllabus in physical track, okay. So, we shall start a new chapter today, hydrogen and its compounds. Okay. So, today we shall start a new chapter, hydrogen and its compounds. Okay. In this lesson, we are totally discussing about three things: hydrogen, water, and hydrogen peroxide. Totally in this lesson we are learning about three main things regarding hydrogen, water and hydrogen peroxide. So the starting one, today we shall discuss about what means hydrogen. After completion of hydrogen, next we shall learn about water, next we shall finally discuss about hydrogen peroxide. Okay, today we shall start our discussion with hydrogen. We know that hydrogen is the starting element in the periodic table. Hydrogen is the starting element in the periodic table. The periodic table start itself with what means hydrogen. And hydrogen atomic number is 1. Hydrogen atomic number is 1. It is the lightest element, we can say. Hydrogen is the lightest element, and we can also say that hydrogen is the most abundant element in this universe. Hydrogen is the most abundant element in this universe. In this total universe, which element is most abundant in nature means hydrogen is the most abundant element in the universe, we can say. Okay, so today we are starting our lesson with what means hydrogen. Hydrogen is the lightest element, we can say, and it's the starting element of the periodic table. Its atomic number is 1. It contains 1 proton and 1 electron. Okay, hydrogen is represented in this way, 1H1. Hydrogen atomic number is 1, as well as mass number is also 1. Okay, regarding hydrogen, what is the first concept we are going to discuss today is hydrogen is the only one element which is not having a fixed position in the periodic table. Remaining all other elements in the periodic table have fixed positions. Hydrogen is the only one element which is not having a fixed position in the periodic table. Hydrogen is the only one element, we can say, which is not having a fixed position in the periodic table. Because the reason what is we can say here means the properties of hydrogen are similar to both first group elements as well as with 17th group elements. Okay, the properties of hydrogen are similar to both the properties of hydrogen are similar to both first group elements as well as 17th group elements. Hence, there is no clarity that where hydrogen should be placed in the periodic table. Whether it should be placed in the first group or it should be placed in the 17th group, there is no clarity. That's why we are saying that hydrogen is the only one element in the periodic table which is not having a fixed position except hydrogen. Remaining all other elements in the periodic table, okay, remaining all other chemical elements have fixed position in the periodic table, but only the hydrogen is not having a fixed position in the periodic table because its properties are similar to both first group elements as well as 17th group elements. Now today we shall discuss about what are the similarities of hydrogen with first group elements as well as what are the similarities of hydrogen with 17th group elements. Both things we shall learn today. Okay. What are the similarities of hydrogen with first A group elements means we can say. First one is electronic configuration. Electronic configuration. Okay, hydrogen is having electronic configuration of 1s1. In the same way, all the first A group elements also having valence shell electronic configuration of ns1. Okay, both we can say similarity is there. Hydrogen also having electronic configuration of s1, and first A group elements also having electronic configuration of s1. Okay, next we can say valence and oxidation stage. Valence and oxidation state. Hydrogen valence is 1. In the same way, first A group elements valence is also 1. Valence is nothing but bond formation capacity. Okay, so one atom of an element is able to form how many number of bonds? It is called as what means valence. Okay, hydrogen is able to form one bond. In the same way, all the first state group elements are also forming only one bond. Next, hydrogen can show oxidation state of +1. In the same manner, all the first state group elements also showing the oxidation state of +1. It is also similarity we can say. In the second similarity, what is there between hydrogen and first state group elements is regarding oxidation state. Hydrogen can show oxidation state of +1. In the same way, all the first state group elements like you can say sodium, Na plus, K plus, okay, they are also showing oxidation state of +1. Next, electropositive nature. Electropositive nature. Electropositive nature. Hydrogen have the tendency to lose electrons. Okay, it is only called as the electropositive nature. Electropositive nature means nothing but its tendency to lose electrons is called as the electropositive nature. All the first state group elements are electropositive generally. They have the tendency to lose electrons. In the same way, hydrogen also have the tendency to lose electrons. Okay, electropositive nature. It is also one similarity we can say. And next one, combining with electronegative elements. Combining with electronegative elements. If you see the first group elements, they generally combine with highly electronegative elements. First group elements, they generally combine with you can take potassium, anything you can take. They generally combine with highly electronegative elements. In the same way, hydrogen also mostly combines with highly electronegative elements. Okay, like you can say HF, HCl, H2O. Hydrogen also mostly combines with what means electronegative elements. And last one more similar to what we can say means liberation at cathode. If you do the electrolysis of NaCl, if you are performing electrolysis of NaCl, sodium will be deposited at cathode. Sodium will be, this is anode, you can say this is cathode. Okay, anode is positive terminal and cathode is negative terminal. Okay, sodium will be deposited at cathode. Sodium will be deposited at cathode. Okay. Sodium will be deposited or liberated at cathode. In the same way, if you do electrolysis of HCl, hydrogen also will be liberated at cathode only. Hydrogen also will be liberated at cathode only. This is all we can say similarities between hydrogen and first year group elements. Hydrogen and first year group elements. So what are the similarities between hydrogen and first year group elements? Means first we can say electronic configuration. Second one is valence and oxidation state. Third one is electropositive nature, and fourth one is combining with electronegative elements, and last one is liberating at cathode. These all are we can say as the similarities between hydrogen and first year group elements. In the same way, what are the similarities between hydrogen and 17th group elements? 17th group elements, we know that they can be also called as halogens, we can call them. What we can call them, mama? Halogens. Okay, so just now we completed about what are the similarities between hydrogen and first year group elements. In the same manner, what are the similarities between hydrogen and the 17th group elements, which can be also called as halogens? Okay, what are the similarities are there, that will also we shall learn. Okay. So what are the similarities between hydrogen and 17th group elements means we can say. Okay, first one we can say non-metallic nature. Non-metallic nature. Halogens, fluorine, chlorine, bromine, iodine, these are non-metals. In the same way, hydrogen is also a non-metal only. Hydrogen is also non-metal. Next one is diatomic nature. Next one is diatomic nature. We see fluorine formula F2, Cl2, Br2. Atomicity you can see here. How many atoms are combining? How many atoms are present in one molecule means two atoms are present in one molecule. And hydrogen formula also H2. Two atoms are present in one molecule. So this one also diatomic in nature, and halogens also diatomic in nature. This is also we can say one of the similarity. Next, electronic configuration. One more thing we can say, electronic configuration. Okay. Next, if you see the electronic configuration of hydrogen, okay, the electronic configuration of hydrogen is 1s1. For its nearest ending gas number is 2. Its nearest ending gas number is 2. It is how many electrons short of getting nearest ending gas number means 1 electron short of getting nearest ending gas configuration. In the same way, if you take fluorine or if you take chlorine, fluorine nearest ending gas number is, okay, you know that neon 10 is the number. Chlorine nearest ending gas number is argon 18 is the number. There are also how many electrons short? There are also how many electrons short of getting nearest ending gas configuration. For getting nearest ending gas configuration, they also still require how many electrons means 1 electron they require. They require 1 electron for getting nearest ending gas configuration, or in order to acquire the aptite group. Okay, so there how many electrons short means 1 electron short. Okay, it is the also one can say one of the similarity between hydrogen and halogens. Hydrogen and halogens. And halogens we can next we can say oxidation state of valence. Halogens can exhibit oxidation state of -1. Okay, in the same way, hydrogen also can exhibit in some compounds. Hydrogen also can exhibit oxidation state of -1. Okay, you can see here NaCl. Chlorine oxidation state is -1. If in the same way, if I take the compound NaH, sodium hydride. If I take the compound NaH, sodium hydride, in this compound hydrogen also exhibiting oxidation state of -1. Oxidation state of -1. Okay, this all we can say is the similarities between halogens and hydrogen. Halogens and hydrogen. Some more differences we can say. Okay. Next, few more similarities what we can say means electronegative nature. So, electronegative nature. We know that halogens are highly electronegative in nature. They have the tendency to gain electrons and form negatively charged ion. In the same way, hydrogen also have the tendency to gain electron and form negatively charged ion. Negatively charged ion. They are forming this kind of anions. Okay, by gaining electrons, they are forming anions. In the same way, hydrogen also can gain electron and form negatively charged ion. Next one similarity we can say ionization potential value. What do you mean by this ionization potential means? We know that ionization potential, it is the amount of energy required to remove an electron. Okay, which is the amount of energy required to remove an electron from an atom is called as what means ionization potential. The ionization potential of hydrogen is almost similar to the ionization potential of halogens. The ionization potential of hydrogen is how much means 1312 kilojoules per mole. This value is almost similar to halogens. This value is almost similar to halogens. The IP value of hydrogen is very much higher when compared to the first A group elements, and this value is almost similar to halogens we can say. Okay, so next, nature of the compounds if we observe here. Nature of compounds. Halogens mostly they are forming covalent compounds. Halogens mostly they are forming covalent compounds. Cl2F2 HF HCl HBr HI. Mostly halogens are forming covalent compounds. In the same manner, hydrogen is also forming which kind of compounds? Mostly means predominantly it will form covalent compounds only. Okay, hydrogen in which way? Predominantly forming covalent compounds. Halogens also predominantly forming covalent compounds. So these are the similarities we can say between hydrogen and halogens. Hydrogen and halogens. Okay, because Since the hydrogen is having some similarities with the first A group elements as well as some similarities with halogens, there is no clarity that where should be hydrogen should be placed in the periodic table, whether it should be placed in along with first A group elements, otherwise it should be placed along with 17th group elements. Okay, there is no clarity. Some scientists argue that it should be placed along with first A group elements, and some scientists argue that it should be placed along with 17th group elements. That's why we are saying that hydrogen is the only one element which is not having a fixed position in the periodic table. Except hydrogen, remaining all elements are having fixed position in the periodic table. Only one element which is not having a fixed position in periodic table is hydrogen. Because of this reason, it is having similarities with both hydrogen, okay, first A group elements as well as with 17th group elements. So that's why there is no clarity that where should be hydrogen located in the periodic table. Okay, so this is the first concept in this lesson, the position of hydrogen. Okay, thank you very much, students.